I'm Karl Kober. We have developed an exploration instrument, the Petro-Sonde, and I would like to tell you about it. Petro-Sonde does three things. First of all, it tells you, without drilling a hole, by using the instrument on the surface, if there is oil, gas, coal, water, or minerals below the surface. Secondly, it tells you how deep the deposit is under the surface and tells you the tops and bottoms of the bearing formation. Thirdly, it tells you what the overburden is, again giving you tops and bottoms of the different lithological overburdens. Now, in simple words, I would like to tell you how the instrument works, and secondly, how you make use of it. In order to use it, you need a field service, and we have been working with Geophysical International, who have trained operators and do, like any logger, custom service. Now, about the workings of the Petro-Sonde. Both the ionosphere and the atmosphere are sending electromagnetic pulses from above to the ground, as shown in this picture. The hatched horizontal line is the Earth's surface, called here the ground. From the air, pulses arrive, like this, and hit the surface, and are partially reflected backwards. At the point of impingement, this point here, the electromagnetic field strength, EXi, of the incoming pulse cancels practically, because the reflected pulse is almost the same strength, but of opposite polarity, which means that if there is a positive pulse coming here, a negative pulse is reflected. However, a small portion of the energy is transmitted into the ground, called ET. Now look at the next picture, and we see what happens to the transmitted pulse ET. At the depth h, we have a different electric resistivity at the horizon, which can be a formation called ρ2, and that is different from the ground resistivity, ρ1. Therefore, the transmitted pulse is reflected at the horizon ρ2, and we have an upgoing pulse EU. Now, the upgoing pulse EU reaches the surface, or the ground-air interface, but here, contrary to what we have seen before, the two field strengths of the incoming pulse and the reflected pulse add up, such that the sensor, or the Petro-Sonde, which is placed in this position, will get the double field strength as an input signal. Now the next picture shows what the Petro-Sonde does with the received pulse reflected from a change in electrical resistivity ρ at depth h. In this picture, we plot again the air-ground interface, but we show now the depth and the frequency content in a logarithmic scale. This is necessary because the relationship between depth and frequency content of the pulse is a complicated formula, and by taking the logarithms we make this a straight line. This area here, this triangle, is called the LFW, or low frequency window, which means that frequencies which are from here to here as a function of depth can penetrate into the ground and come up again and give us the message of what is happening in the ground. Now, if the ground is a homogeneous ground, we would have a constant line here. However, the ground is not homogeneous, but consists of shale, limestone, shale, sandstone, again shale, with different resistivities. Therefore, this border of the LFW is not a straight line, but jagged, like shown here. And this is where the information comes to the instrument. For instance, if we have a filter for the low frequency window and tune down in depth, we get different frequency contents in the window up to the sensor, as shown here by the vertical dashed lines. For instance, if we have shale, we go along this line, and suddenly here comes limestone, and we get a higher frequency here, constant again, get a lower frequency, come down, get a much lower frequency, and so on. Now, by using in the sensor a tunable filter, we can achieve this operation, and whenever the resistivity in the underground changes while we tune, we get in the filter at the output a transient, as shown by these pulses. And these pulses we pick up with earphones, and the operator then reads, when the arrival of a pulse occurs, the corresponding depth and enters this in the log. Now we have seen how the instrument picks up the transients, and the transients have a very characteristic sound. If it is just formation changes from limestone to sandstone, the sound is kind of subdued. However, if it comes to oil, gas, water, coal, or mineral, which have more drastic changes of resistivity, then you get stronger sounds and very characteristic signatures of the occurrence of the economic deposit. And the operators are trained to pick this up. Furthermore, by noting the depth where those sound changes come in, the operator, with a couple of feet of error, can list bottoms and tops of those economic deposits down to 20,000 feet depth without drilling a hole. Now, therefore, the total operation consists of two portions. One, you have to have the Petro-Sonde. Secondly, you have to have well-trained operators, and the secret is their training, that they recognize not only formations, but the kind of economic deposit. And all this you can have from Geophysics International.